Hi there, so today we're going to solve Leetcode daily challenge, problem number 1339, maximum product of splitted binary trees. So the problem given over here is, given the root of a binary tree, split the binary tree into two subtree by removing one edge such that the product of sum of the tree is maximized. And we have to return that result in a modulo of 10 to the power 9 plus 7. And yeah, and we have to take the modulo after computing everything. So what we have to do over here is we have to find out two subtrees such that their sum, like the sum of those individual subtrees, when multiplied gets maximum, right? So my plan is to calculate the sum of a node and all of its child. Okay, for example, at this node, at the fourth node, we are going to have the total value as 4 with the fifth node. Like these are the leaf node, because that's why you're not taking the child weights or child values as a sum. It's going to be 5. But when you move to the 2 over here, the sum is going to be 5 plus 4 plus 2, which will be 11. Okay. Similarly over here, we are going to do the same. And what we will be doing is we will just prepare all these value sum at each individual node. And once we have that, what we are going to do is we are going to simply check if we remove this particular edge. For example in this case, let's say we'll go with example over here. So 4 plus 5 plus 2 11 over here, then 6 3 9, and we had 11 plus 9 20, and 21 was the total at the root node. Okay, so let's say now I remove this particular edge, the edge with the node 4. Then what I'm gonna have now is 17 into 4. Okay, similarly we will try with all the edges, and I'm gonna return the maximum value uh, with the same flow and with the same logic. So let's start the code and I'll explain you on the code. First, what I want to do is I want to create an array for the total at each node. Okay, now I will be traversing the list in a pre-order manner, post order, I think I should say. Yeah, in the post order. Okay, and first check, of course, if a node is not valid, simply return 0. For example, if we go beyond beyond the leaf node, we'll get a none, right? And none has a value of 0, so we're gonna return 0 from this point. Then node sum will be equal to node dot value plus post order. I will be calling node dot left plus post order node dot right. Okay, so what we're doing over here is, for example, at the leaf node, I'll get 0 from the left subtree, 0 from the right, and the node will have a value of 4. So at this node, the total will be 4. Similarly, for this node, like the node with the value 2, what we're going to have, we're going to have 4 plus 5 plus 2, right? And I want to add this node sum into our array which we are preparing. Node sum, and at the end, I want to return the node sum from this function. Okay, now what we have to do is we have to initiate this helper method with the root value so that we get the total at the root node. Okay, so total at root will be post order of root, and I'll be taking another variable, maximum product. This will be the result of our code, and I'll initialize that with 0. Now we simply just have to traverse the array which we have prepared, and we'll just see eliminating each edge at a time. And I want to update, sorry, my maximum product. So we're gonna take the maximum of the maximum product at the current moment and value into total at root minus value. Okay, and at the last I'll simply return the maximum of products. So let's see. So the test cases got passed successfully. Let's submit for further evaluation. Okay, it got a wrong result. Okay, that's fine. Let's see. Total at root. This is fine. Hmm. If node is 0, okay, then what should have happened? Oh, we forgot to do the modulus, right? I think that should be 9 zeros and 7. Okay, 2, 3, 6, 8, and 9. I think this should work. Yep. So the solution got accepted successfully, and we performed decent, I think. So thanks a ton, guys, for watching the video, and stay tuned for the upcoming ones. Thank you.